Hello everyone, welcome to Simple Science, where we aim to explain simple scientific concepts. And in this video, I'm going to quickly explain and introduce momentum and impulse for the next video, which is going to talk about the conservation of momentum. Okay, so this is just a quick video, an introduction between the two and how they're different. Okay, so many of you may know that momentum is defined as the product momentum of an object is defined as the product of its mass and velocity. So P, as we like to denote momentum as, equals to mass m times v, the velocity. And momentum is often very difficult to visualize. And I would like for you guys to think of momentum as how difficult it is to stop an object that is moving. So look at this truck of 10,000 kilograms moving at 10 meters per second. It's obviously very difficult to stop this thing from moving. But if it's heavier, it's 20,000 kilograms, then of course it's going to be even harder. So the greater the momentum, and the harder it is to stop that object from moving. Or if it's moving faster, if it's moving at 50 meters per second, of course you need generally a greater amount of force, given that time is the same. Basically, it will be harder if the momentum is larger. So the larger momentum, the harder it is for that object to stop moving, basically in its motion. So quickly, I'm going to explain how we're going to calculate momentum of this car and this truck. So let's calculate the momentum of this truck. It's P equals mv, very simple. It's 10,000 kilograms multiplied by 10 meters per second gives you 100,000 kilogram meters per second. That's the unit for momentum, by the way. And for this car, P equals mv, and momentum is equal to 2,000 kilograms multiplied by 0 meters per second gives you 0 kilogram meters per second square per second. Okay. Now that's basically momentum. That's a quick introduction to momentum. Now let's look at impulse. What is impulse? Now we need to bring back this knowledge of force is the rate of change of momentum. So force is equal to delta mv over delta t. Okay. Delta mv is the change of momentum, and t is the time taken, basically. And you can rearrange this equation to give you F multiplied by delta t, force multiplied by time, is equal to the change of momentum, or delta mv. And impulse is basically delta mv. Impulse, another way of saying impulse is the change of momentum. That's it. The impulse is the change of momentum. Impulse is the change of momentum. Get it in your head. So impulse is basically, therefore, F multiplied by delta t, as we saw in the second equation above. Impulse is the change of momentum is equal to force times the time taken in which that force acts. Okay? Good. Now let's look at a quick example. A force of 5 Newton acts on an object of mass 5 kilograms initially moving at 20 meters per second for 10 seconds. So that force, 5 newtons, acts for 10 seconds on this object. So find the object's final momentum after 10 seconds. So first of all, we got to find its initial momentum. That is, 5 multiplied by 20 gives you 100 kilograms meters per second. And from basic deduction, we know that final momentum is equal to initial momentum add the change momentum. That goes for everything in physics. Final equals initial add change. Okay? So we know the initial. So to find the final, we need to know the change momentum. So the change momentum is force times by time taken, or force times by time taken. So that is 5 newtons times by 4 seconds gives you 20 kilograms meters per second. That is the change of momentum, and therefore the final momentum is equal to the initial add change. So it's 100 add 20 gives you 120 kilograms meters per second. Okay? Thank you for watching and have a nice day.